Now things get tricky. Up until this point, we have been given the radius and the angle, and we've just cranked it out. And by this point, it kind of got a little bit boring because all I needed was right there. They either gave us the angle or they gave us the proportion that we're dealing with. Now, we're going to be asked to find the radius. So what's the radius of a quarter circle with an area? All right, stop right there. You're dealing with area. So area equals, and this is a quarter circle, so this is a sector, like a slice of pizza or pie. And this is going to be the angle divided by 360, if you want to write the formula again, multiplied by pi times the radius squared. Now, I'm actually about to ditch this formula in the proportion sense. Angle divided by 360. Well, they're not giving me the angle measurement, but they sort of did, right? The quarter circle, they went ahead and told me that this was 1/4, which would be 90 over 360. So I do know that this is 90 over 360. Let's just call it 1/4. Don't complicate your life. And then pi times the radius squared, because we don't know the radius, but we do know it's 81 over 16 pi, 81 pi over 16. Okay, and now we get into some territory where a lot of students really struggle to solve things that look like this, and there's several different strategies for doing it. Here's what I think, personal opinion, works best, and it's to make everything a fraction and then go from there. So fraction, happy over here, fraction, not really. But this is pi r squared over 1. So what I'm going to do, I'm going to bring my work up here. 81 pi over 16 equals 1 times this, which would be pi r squared, and that is over 4. So what I'm going to do now is solve for r simply by, I would say cross multiplying, but I'm not actually. I'm not even going to cross multiply. What I am going to do is multiply by the things and divide by the things that are surrounding my r squared, and that will help me isolate it. So for example, I can multiply by 4, and it will cancel those. I can also divide by pi. So I'm going to multiply by 4 over pi on both sides. So let's do that. Let's multiply by 4 over pi. Looks a little sloppy, but it'll work. And now we have r squared equals, and I'm going to cancel my pi's here, and I'm also going to reduce, just like I've been reducing in the past. So 4 goes into itself 1 time, 4 goes into 16 4 times. And I'm left with 81 over 4. Okay, well that's great. That's great. But that's not r, that's r squared. So if I wanted to solve this, I would actually need to square root that. And when I do, running out of room again, we're going to take the square root of 81 and the square root of 4. So r is 9/2, and they did not give me any units. So maybe it's inches, maybe it's centimeters, maybe it's whatever. So 9/2 is good. If you want to call it 4.5, that's fine too. You can say 4.5 equals r. So is there another way of doing this? Absolutely. Yeah, there are a lot of different ways. I do want to go back for just about a minute and say that when you're multiplying this stuff together to make it one fraction, it's 1 times this, because this is a numerator, and then 4 times an understood 1, right? So you multiply fractions, you multiply the numerators, multiply the denominators. Okay, let's move on to the next one. What is the angle measurement of an arc that, okay, an arc. This is the arc length. Let's write that formula. Angle over 360 times 2 pi r. Okay, let's start just running through this thing. What is the angle measurement? We don't know what the angle measurement is. Call it x if you want to. I'm going to call it x over 360. Arc measures 1.5 pi. Okay, 1.5 pi. And the radius is 6. 2 times pi times 6. Okay, you don't have to do it this way, but I like to make everything one fraction on each side. So running out of space, I'll bring my work up here. 1.5 pi, you could call that 3 pi over 2, just saying. I'm gonna put it over 1, just saying. I'm gonna leave a little gap because I know I'll need it. And then I'm gonna have x times 2 pi and 6. Okay, let's do some common sense stuff. 2 times pi times 6, that's 12, and then a pi, because 2 times 6, right? And I am multiplying by x. Okay, so it's like x times all this stuff, and my denominator is 360. Okay, degrees. May as well, why not? So I want to solve this for x, and if I'm going to solve it for x, then I can multiply and divide appropriately, and just multiply by 360, and it cancels those. Multiply by 360 degrees here, which creates the units of degrees that I need. And I can also divide by 12 pi and divide by 12 pi. Okay, so what we have done on the right side is the easy stuff. That's where things cancel and you're left with x equals. That's going to give me my degree measurement. But on this side we have somewhat of a mess, and you could totally type it into calculator, Desmos, whatever, but I'm going to do as much of it in my head as I can because it's kind of doable in your head. Pi cancels. Please do that in your head at least. And then 360 divided by 12 is 30. 30, this is 30, times 1.5. Well, 1.5 times 30 is 45 degrees. All right, just in case you need to see it, here's what really just happened. We did 1.5 times 360 over 12, and we got 45. But try as much of it in your head as you can. An arc intercepted by a 50-degree central angle has a length. Stop right there. You're dealing with arc length. Or are you? Let's find out. Length equals area. Whoa, 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 angle, my bad. Angle over 360 degrees times 2 pi r. Just start from there. Haven't even read the rest of the problem yet, but let's just go. We know we have a 50-degree angle, 360 degrees here, 2 times pi times, oh, they didn't tell us the radius. Oh, well. But they did tell us the length, which was 40 over 9 times pi. I'm going to call it 40 pi over 9. Totally legit. It works. 40 pi over 9. Okay. Clearly, before I even read the rest of the problem, I know I'm kind of stuck until I find the radius. So what is the area of the corresponding sector? So the second part of this question is, hey, tell me that area, which would be the angle over 360 times pi times the radius squared. And in order to do it, I need the measurement of the angle. I know it. Let's just keep going. 50 over 360. And I need the radius. I don't know that. So here's the problem. In order to finish this problem, I need the radius, and this is the work that will lead me there. So we actually have just done this concept. We did something similar here. Not exact, but similar. And from here, we'll be able to actually answer the question. So let's keep going and do it all kinds of ways, but I'm going to do it the way I've been doing it, where I bring my work up here, save some space, and we'll have fraction equal to fraction. So 50 times 2 times pi times r, that's going to be 100 pi r, and then 360. I'm going to drop the degree symbols because they do technically cancel in that context. And I will multiply by, didn't leave myself much room to write it on the left side of the equation, but I'm going to multiply by 360 and divide by 100 pi. And that's the easy part because cancel, 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 cancel. But over on this side, we're going to have 360 over 100 pi. Okay, terrible handwriting, but good math. Okay, right side of the equation is r, just r. That's what we're left with. On this side, we cancel the pi's. We're going to have, oh goodness, we can do some of this in our head. We can do most of this in our head. 360 over 100, that's 36 over 10, 40 over 9. By the time we talk through this thing, let's just grab a calculator. Much fun as it would be to do this. 16. The radius is 16. Now, they didn't give us units, centimeters, inches, miles, light years, who knows. And we are going to take that 16, plug it in right there, and we're about to crank out an answer. Now, they might ask us in terms of pi. They might also ask us just, you know, like multiply, get a decimal. Based on the fact that this was in terms of pi, I'm going to continue with this concept of just keeping it in terms of pi, which means we'll have 50 over 360 times 16 squared, and it's that. We'll put this in terms of pi. 320 over 9. 320 over 9 pi. Pi can go in the numerator as well.